Hi, in this lesson I am discussing Edexcel IAL May 2020 or October 2020. Both are the same paper, Unit 4 Physics paper. In this lesson I am discussing questions from 14 to 18 on 14 to 18. In my previous video, I discussed questions from 1 to 13, and if you want to watch that discussion, you can see the description of this video. There, the link for the previous video is given, so you can get the link or URL for the previous video from the description of this video. Okay, question 14b part. This is about Rutherford alpha particle scattering experiment. Rutherford wrote the main deductions from the theory are independent of whether the central charge is positive or negative. Yeah, so from the deflection, we can't deduce whether the nucleus is positive or negative. So discuss why the observations did not allow Rutherford to conclude whether the central charge is positive or negative. You may wish to use diagrams to illustrate your response. Okay, so I'll use a diagram, two different diagrams. By using those diagrams, I can explain why can't we conclude whether nucleus is positive or negative. Okay, so in this Rutherford alpha particle experiment, the conclusions were made based on the position where the alpha particle hits the, the spherical shape zinc sulfide coated glass bulb. Is it at which position the scintillations or the glow observed? At those positions, the alpha particles are hitting. So by using that position, the angle of deflection was able to measure, and from that only they were able to give three different conclusions, whether most of the alpha particles went straight and few alpha particles has deflection less than 90 degree, and 1 in 8,000 alpha particles almost bounced back or almost reflected back. So those conclusions are made by using the position at which the scintillation or the glow observed on the zinc sulfide screen. Okay, so to get such conclusion, okay, now look at here. If the alpha particle is positively charged, what will happen? If the nucleus is positively charged, what will happen? When the alpha particle moves far away from the nucleus, will be pushed away like this, and you will see the scintillation at those positions. Okay, if the nucleus is negatively charged, what will happen? The alpha particle will be pulled towards the nucleus or will be attracted towards the nucleus, and they will deflect as shown in the diagram, and they'll produce scintillation at those positions. Okay, so you can't follow the path of the alpha particle. Only thing you can see the positions at which you get or observe the scintillation. Okay, now look at here. In this also you are getting scintillations on the zinc sulfide screen at those positions. Here also you are getting the scintillation at those positions. So from these two observations, when you compare, you can't say whether a nucleus is positive or negative, whether these scintillations are produced due to attractive force on the alpha particle by the nucleus or by the repulsive force exerted on the alpha particle by the nucleus. We can't give a conclusion. Also, we say 1 in 8,000 alpha particles almost bounced back. So that also happens like this. If the nucleus is positive, the alpha particle will be repelled and it will experience a repulsive force, and it can turn like this and hit the zinc sulfide screen here and produce scintillation here. Okay, if the nucleus is negative, what will happen? The alpha particle will be pulled towards it, so it can go around the nucleus and move to this direction and produce scintillation here also. So by using these two observations also, we can't conclude whether nucleus is positive or negative. So that's the problem. Rutherford did not say in this conclusion whether the nucleus is positive or negative, because we can't give a conclusion by using only the observations formed or produced on the screen in the form of scintillation. So this diagram clearly shows the observations are the same. As I told earlier, the observation and the conclusions. So the conclusion is made based on the observation. So observation will be the same whether the nucleus is positive or negative. Okay, question number 14, C part. Uh, the question says, we know that the nucleus is positively charged. An alpha particle with kinetic energy 6.29 mega electron volt approaches the platinum nucleus and is repelled. The proton number of platinum is 78. Okay, calculate the minimum distance of the alpha particle from the platinum nucleus. Assume that the two particles, the nucleus and the alpha particle are point charges. Okay, so here we can draw a diagram, simple diagram for the part C. So the alpha particle is approaching, this alpha particle is approaching towards the nucleus. So this is the platinum nucleus. Okay, so when the alpha particle reaches this point, it lost all its kinetic energy. That means the alpha particle's kinetic energy becomes equal to 0. Here the alpha particle has kinetic energy that is 6.29 mega electron volt. So here the kinetic energy of the alpha particle becomes equal to 0 because when the alpha particle moves from here to here, it experiences electrostatic repulsive force. It will lose its kinetic energy due to work done against electrostatic repulsive force. It's an opposing force. So the closest distance it approached from the platinum nucleus, we can take it as x. That's the closest distance it approached. Okay, so here I can do like this rather than finding the force, and the force is going to change when the alpha particle gets closer. F equal k q1 q2 r square according to Coulomb's law. When it gets closer and closer, the distance is changing, so it's difficult. Actually, we won't be able to handle any calculation based on force and distance. But I can use an equation. The alpha particle, now when I throw this pen vertically upwards, initially it has kinetic energy. When it moves upwards, here also the pen is experiencing opposing force, so it's losing the kinetic energy and gaining the gravitational potential energy. Similarly, here when the alpha particle moves from this point to this point, it's losing the kinetic energy and gaining the electrical potential energy. So the electrical potential energy gained by the alpha particle, is given by electrical potential created by platinum at point x times the charge of the alpha particle is the electrical potential energy of the alpha particle at the position closer to the platinum nucleus. So what will be the electrical potential energy of the alpha particle when it is far away from the platinum nucleus? The potential is given by kq over r, where q is the charge of the platinum nucleus into q alpha. So when the alpha particle is far away from the platinum nucleus, R will be larger, so it won't have any electrical potential energy when it is far away from the platinum nucleus, or initially when it is at far distance from the platinum nucleus, it has no electrical potential energy. But when it gets closer to the platinum nucleus, R is decreasing, so there will be electric potential created by the platinum nucleus. So alpha particle will have electrical potential energy. So here I can write the equation loss in electrical potential energy. For alpha particle, I can write for alpha particle loss in kinetic energy equal gain in electrical potential energy. Loss in kinetic energy, initial kinetic energy is given, that is I can say initial kinetic energy minus kinetic energy finally, that is 0, because they are saying it's approaching a closest distance, means its speed becomes 0. Gain in electrical potential energy, final electrical potential energy is equal to potential of the platinum nucleus into charge of the alpha particle, W equal QV. You know that electrical potential energy is due to the work done against electrostatic force, W equal QV. So electrical potential energy, V into q alpha. V is given by kq over x. I'll say the distance, closest distance is x. Kq, where q is the charge of the platinum nucleus, over x into charge of the alpha particle. So same way, the electrical potential energy of the alpha particle when it is far distance from the platinum nucleus is 0. I already explained that. Okay, so substitute the values here. You can find the kinetic energy initially is given as 6.29 mega electron volt. Mega means 10 to the power 6. Convert electron volt to joule, 1.6 10 to the minus 19. The final kinetic energy is 0 because the alpha particle is coming to momentarily rest at that point, closest point. Equal K is 8.99, 10 to the power 9. Charge of the Q is the charge of the platinum nucleus. They are saying it consists of 78 protons. So 78 into each proton 1.6 10 to the power minus 19 over x into charge of the alpha particle. You know alpha particle plus 2. So 2 into 1.6 10 to the power minus 19. Solve it and find the x. You will get 3.57 10 to the power minus 14 meters. Okay, so question number 15, A part, it's about mechanical mouse trap. So there the lever is moving from this position to this position. So when it is moved, the force applied on the lever is changing, but force is always applied perpendicular to the lever. So the distance moved by the lever is 1/4 of the circumference. So that is pi r by 2, you know, one full circle 2 pi r divided by 4. So that's the distance moved. So since the force is applied always perpendicular to the lever, so work is equal to force into the distance moved. Distance moved will be this one, that is pi r by 2, since the force is always perpendicular to the lever. So the lever is moving on a 1/4 of the circular circumference. Okay, so the force is changing, uniformly is changing due to the extension of the spring. Force is uniformly changing. So the work done, that will be the energy stored in it, average force into distance. So average force, how can we find? Find the average of these two, 2.6 plus 9.6 divided by 2, because the force is changing uniformly. That's the way the question is saying. So we can find the average force into distance moved is pi r by 2. So that is 2.6 plus 9.6 by 2 into pi into the length of the lever is given as 4.9 centimeter. So 4.9 convert to meter, 10 to the power minus 2 by 2. Okay, so the answer is 0.47 joules. So that's the work done. So the energy stored in the mechanical mouse trap also, when you are pulling the lever through 90 degree. So the energy stored in it also the same. Okay, so B part of question number 16. Sorry, question number uh, 15. It's about transformer. So not a big thing. Normally this question comes. First you should explain how the question is. They are giving a transformer. So it converting DC to AC. Then there's a transformer. Then on the output of the transformer, there is a AC to DC converter. That's a rectifier. Then the capacitor is connected. So the question is, explain how applying potential difference across the input coil causes the capacitor charge. Okay, not a big thing. You can first say the input signal is a varying because they are using DC to AC. They are using an oscillator, so converting DC to AC. So first you should say in the input coil there is a AC voltage is applied that will produce AC current in the input coil. This AC current will produce varying magnetic field around the input coil. This varying magnetic field will be transferred through the iron core to the secondary coil. You can say the iron core will become electromagnet, and the varying magnetic field will be transferred from the first coil to the input coil to the output coil through the iron core. So there will be magnetic field passing through the output coil. So there will be magnetic flux linkage with the output coil. This magnetic flux linkage is going to vary with time because the magnetic field is varying. So there will be a rate of change of magnetic flux linkage with the output coil. So then you can say, according to Faraday's law, there will be voltage will be induced across the ends of the output coil, right? So there will be induced voltage, and that induced voltage is connected to capacitor. So it will form a closed circuit because they are converting that varying voltage across the output coil into DC current, right? Into DC by using a rectifier, and it's connected in a closed circuit. So there will be current flow through the capacitor, and the capacitor will get charged. So that's the answer, very simple answer. Okay, so this is the answer for the question 15 B part. Okay, question 15 part B, second part. There's a graph is given. I didn't draw the complete graph. It's given on a grade on the exam paper. The graph shows how the magnetic flux density, that is magnetic field strength, be varying with time. So the question is, show the maximum potential difference across the output coil about 600 volt, that we have to show that. Number of turns given 1700, and cross sectional area of the coil also given. So this is the magnetic field strength, the variation of magnetic field strength in the iron coils given. So now the question is, find the induced voltage, maximum output voltage. So you know the induced voltage across the output coil is equal to, according to Faraday's law, rate of change of magnetic flux linkage, so d phi by dt. Or I can say, we won't be able to use the calculus in A level, but we know maximum change in flux over time taken, rate of change of flux must be maximum. But we know that d phi by dt means, phi is equal to BAN. So here area is not changing, the area of cross section is not changing, number of turns not changing. So change in flux is due to change in B. So if I want to find the maximum induced voltage, I need maximum rate of change of magnetic field strength. So this I can say the variation in magnetic field strength divided, variation in magnetic flux divided by the time. So d phi by dt is going to be rate of change of magnetic flux linkage, and that should have the highest value. We will be able to get the maximum rate of change of magnetic flux linkage when the rate of change of magnetic field strength is the maximum. So what should we do? Draw a tangent to this graph and get the maximum gradient. Maximum gradient to get, you keep the ruler like a tangent. Where your ruler is getting more vertical, draw the tangent at that point. So I'm getting the graph more vertical. The tangent becomes more vertical when I'm keeping it somewhere here on the grid. So draw a tangent here somewhere like this. Draw a tangent and find the gradient of the tangent. That will give the maximum gradient. Okay, so when the gradient maximum, rate of change of magnetic field strength will be the maximum. When the rate of change of magnetic field strength becomes maximum, rate of change of magnetic flux linkage will become maximum. So induced voltage will become maximum. So find the maximum gradient. You should keep the ruler and draw somewhere here. And when I find the maximum gradient, so I'll get maximum gradient. So that is something like, I got this value 8 into 10 to the power minus 3 minus 7.6 10 to the power minus 3 over 3.4 10 to the power minus 5 the time minus 1.8 10 to the power minus 5. So I got 975. That's my answer. It might be different for different strength depending on the position at which you are drawing the maximum gradient. Okay, so I need to find the induced EMF. So this is the maximum gradient. So E max is equal to d phi over dt. That should be the maximum. So I can see A n, phi equal B A n. So the variation in flux is due to variation in B. So rate of change of flux is due to rate of change of magnetic field strength. I found the maximum value. So I can say A n times d B over the gradient of this one. I can say dB over dt maximum. dB over dt maximum is the gradient of B against time graph. So you know dB over dt, you learned that in even velocity time graph, dV over dt gives the acceleration, that's a gradient. dx over dt gives the velocity, that's a gradient of displacement time graph. Like that, dB over dt is the gradient of magnetic field strength against time graph. That maximum I found in 975. Now substitute the values. I know the area of cross section that is given 3.5. 10 to the power minus 4. Number of turns given 1700. And I know the maximum gradient 975. So when I solve, I get 580 volt. So approximately 600 volt. Okay, so question number 15, part C, how the potential across the capacitor varies when it discharges through a resistance of resistor. 3000 ohm is given on a graph, voltage time graph. So it's given on a grade. And the question is, determine whether the mechanical or electrical mouse trap stores the most energy. We found the amount of energy stored in the mechanical mouse trap. We found it in the first part. We got that energy is 0.47 joule. So we need to find the energy stored in this mousetrap, which is made of, which consists of capacitor. Okay, so I need to find the energy stored on it in the capacitor. So we know the energy stored in the capacitor is half CV squared. So from this graph, I need to find the capacitance of the capacitor. I can use the half-life. So I know the capacitor graph given. Initial voltage is given 600. So I'm not going to find the half-life. So from the graph, when I observe, the time taken for the voltage across it to drop to 300 volt is 3.1 second. So the half-life is 3.1 second. I can use the equation T half equal RC ln2. I can use it. If I use RC ln2 means T half, I know that 3.1 is equal to R is 600, 3000 given in the question paper. 3000 times C time ln2. Find the capacitance. You will get the capacitance will be equal to 1.49 into 10 to the power minus 3 farad. Okay, so I need to find the energy stored in the capacitor, that is given by half CV squared. So the maximum energy will be stored when the voltage is the maximum, which is 600 volt. So half into capacitance 1.49 10 to the power minus 3 into 600 squared. So the energy stored in the capacitor, maximum energy will be 268.4. Okay, so we know that this capacitor consists of more energy than the mechanical mousetrap. So we can say the electric mousetrap consists of more energy or stores more energy than the mechanical mousetrap. Question number 16 about 16a, circular motion. So derive the equation A equal V squared OR. I am not going to do it because you can find it in any book. So waste of time doing it again. So you can find it from any textbook, and most of your teachers would have done it. Okay, so B part is there's a photograph given about a toy with small aeroplane suspended from a canopy by wires. So the platform rotates and the aeroplane rises and follow a circular path. So there's a diagram. I'll draw it here. It's a photograph. So there are aeroplanes, small toy aeroplanes. I drew them like a small sphere. And this wheel kept on the top is rotating. So the string is attached to the rim of the wheel. And when it rotates, these aeroplanes, toy aeroplanes are moving on a circular path. Okay, so first part, complete a free body force diagram for one of the aeroplane at this speed. So if I consider this one, first part, you know the forces acting on it as the weight downwards and the tension acting on it this direction. So angle also given 19 degrees, so we should show that angle also. This is 19 degree. Okay, the second part they are telling the mass of the aeroplane is given and the diameter of the circular path of one of the toy plane is given 10.8. So I showed the radius, half of it, 5.4 centimeter, 5.4 centimeter. And the question is, show that at this speed, so the angle is 90 degree, it's given there. Uh, Show at this speed the time for one aeroplane to make 4 complete rotations is about 3 seconds. So I'll find the time taken for one rotation, that is the period of circular motion, and then we will find the time taken for 4 rotations. So multiply the time period by 4. Okay, so what are the equation? Can I write it here? So for this, when I consider the vertical motion, there is no vertical motion, so it's moving on horizontal circular path. So according to Newton's first law, the resultant vertical force must be equal to 0. So I can say T cos 19 equal to mg, or T cos 19 minus mg must be equal to 0. I can take it as first equation. So the second equation, I know the centripetal force should be towards the center. So that will be T sine 19. So the centripetal force is provided by the horizontal component of the tension. So that's going to be T sine 19. So T sine 19 equal to mr omega squared. You know mv squared over r, or mr omega squared is the centripetal force. I use mr omega squared because I want to find the omega, and from that omega I am going to find the time period. Okay, so here I can divide these two equations. So divide the second equation by the first equation. I'll get T sine 19 over T cos 19 is equal to m, and m will get cancelled, r omega squared over g. So tan 19, will be equal to r omega squared over g. Substitute the values. R is given 5.4, 10 to the power minus 2, omega squared over g 9.81. So from this you can find the omega. So omega will be, you will get 7.91 radian per second. We know omega equal to 2 pi over t, that is equal to 7.91. So find the time period for one rotation. So that will be 2 pi over 7.91. So time taken for 4 complete revolution will be 40. So time for 4 rotations, multiply this by 4, that will be 8 pi over 7.91. So the final answer will be 3.2 seconds. So approximately 3 seconds. Okay, so we third part of question number 16. It says student A suggests, there are two statements given. Student A suggests that if the radius of the canopy was increased and rotated at the same angular velocity, as before. The wires supporting the aeroplanes could be vertical. Student B suggests that the wires could be at an angle of greater than 19 degree to the vertical. So if you increase the radius of the canopy is the circular disc from which the strings are attached. Okay, so you can see that here the canopy, this one, its diameter, the radius is R. I can say this as capital R, the radius. Okay, so the radius of the circular path depends on the radius of the canopy. So if the radius of the canopy increases, the radius of the circular path also will increase, but there is no change in its weight. So if there is no change in its weight, that means the vertical component of the tension will remain the same. Is it? Vertical component of the tension will remain the same because weight is not changing, and also the angular speed is not changing. So better we will get the same equations as I told earlier. So you know our radius is going to increase. When the radius increases, the centripetal force F equal mr omega square will increase when the radius of the canopy increases. Radius of the circular path is increasing, so centripetal force will increase, right? So now when you think about the first statement by the student A, he says when you increase the radius of the canopy, the string will become vertical. That is not possible. It's a wrong statement because if the string becomes vertical, then the theta will become equal to 0. When the theta becomes equal to 0, there won't be any horizontal force because you know the required centripetal force is provided by the component, the horizontal component of the tension, that will be equal to 0 if the string becomes vertical. So anyway, that statement is wrong. You can say when the string becomes vertical, there won't be any horizontal component of tension. Therefore, there won't be any centripetal force. Therefore, there can't be a circular motion. So student A is wrong. Perfectly, we can say he is wrong. We need to analyze the student B, his statement. He is saying the theta will become large when the radius of the canopy becomes large. We'll analyze that. We know that when the radius of the canopy becomes large, R will become large. When R becomes large, centripetal force will become large. So we know that centripetal force is given by T sine theta. I can take it as equation 1. When I consider the horizontal vertical component, T cos theta equal to mg, there is no change in the weight, so there is no change in the vertical component. So I can rewrite this as mg equal t cos theta, both refers the same. Okay, divide equation 1 by equation 2, you will get it. M and M will get cancelled. R omega squared over G equal tan theta. So this equation clearly shows, because the question says the angular speed remains the same, only the R is increasing. When R increases, tan theta will increase. When tan theta increases, theta will increase. So the statement by the second student is correct. So here, this is the answer you can write. This is for the question number 16, part 3. Okay, question number 17 about particle physics. So cloud chambers are used to observe the paths of particle. You know, in cloud chamber and bubble chamber, only the charged particles can produce track. Neutral particles won't produce track because they won't ionize the medium. Only the charged particles can ionize the medium and produce the track. So the photograph shows a pair of tracks made by alpha particles emitted when an atom of radon decays in a cloud chamber. And they are given two tracks. One track is like this. This is the second track. And this is the first track. They named it track 1, track 2. So a part, a radon atom do not leave tracks. State a reason for this. Actually, The reason is, radon atom is a neutral particle, therefore it won't be able to ionize the medium, so it won't produce any track. So it won't ionize the medium, so no track will be produced. B part, question number 17. Radon decays by emitting an alpha particle producing a polonium nucleus. The polonium then decays almost immediately by emitting another alpha particle. Complete the nuclear equation for this sequence of decay. So equation is given, it's an incomplete one. We need to complete the decay equation. Okay, so here what's happening? Radon is decaying and it's producing polonium. Then polonium is decaying and producing another alpha particle. So total number of alpha particles produced is 2. So I should write here 2. We know alpha 42, that you must remember, alpha 42. Now balance it. So 2 into 2, 4, here 82. So it must be, this is 82 and 4, 86. So this must be 86. Same way, balance it. 2 into 4, 8. So here 220. This must be 212. Okay, so second part, question number 17, B part, second part. The radon atom was stationary before decay. So initially the radon was stationary before the first alpha emission. The angle between the two alpha tracks is 60. So these are the two alpha tracks. So this is 60 degree. They are saying it. So the question is, sketch a vector diagram to show the momentum of the two alpha particles and lead ion. Okay, so now what's happening? So we'll analyze it first. Now what's happening? Initially, there's a radon. So radon was stationary initially. Then radon is decaying into polonium. So actually what's happening? Initially there is radon. Radon is decaying into polonium and creating, polonium and alpha particle. So one of the tracks belong to this alpha particle. So we don't know which track. We'll take this one, the first track, as the alpha created by first decay of radon into polonium. Then polonium is decaying again. So this polonium is decaying again and producing. So there's a less time delay. So almost immediately polonium is decaying into lead and it's producing another alpha particle. Okay, so totally there are two different alpha particles produced. So the two different alpha particles are producing two different tracks and the angle between the two tracks is 60 degree. This was initially at rest. So they ask you to sketch the vector diagram to show the momentum. Okay, we'll think like this. So I took this one as the track of the first alpha particle when radon decays into polonium. So radon was initially at rest. Imagine radon was initially at rest and it's producing first track and polonium. So when the alpha particle is emitted, the first alpha particle is emitted this way, we'll first sketch a rough diagram to understand the question. So if this is the first track produced by the alpha particle, then what will happen? The polonium will recoil in this direction. Polonium will recoil in this direction because to conserve the momentum. Initially radon was at rest, means initial momentum is equal to 0. So the alpha particle has momentum this way. If I say this is the momentum of alpha particle, that's the direction of motion also this way. If I take it for the alpha particle, track is given like that. So the momentum of the PB must be this direction. Both should have the same magnitude but in opposite direction. Why? To conserve the momentum, because initial momentum equal to 0. Right. Now immediately the PB is decaying into polonium is decaying. This is polonium. Sorry, I made a mistake. This is polonium. So once again I am saying radon is decaying into polonium and alpha. The first alpha particle is this way. Its momentum is this way. So the momentum of the polonium must be this way to conserve the total momentum, because initially it was at rest. So these two should have the same magnitude of momentum in opposite direction. Okay, then polonium is decaying into alpha and Pb such that the second alpha is making 60 degree with the first alpha particle, the directions. So what will happen? The first, when the polonium decays, the polonium is moving this direction. So polonium has momentum this direction. Momentum P of polonium is this direction. So it has an alpha particle that is making 60 degree with the first alpha particle. Means it can go like this. The first alpha particle vertically down. The second alpha, which is produced when the polonium decays, should have a direction this way. So P2 alpha I can say. So this one, and the momentum of the PB must be this way, because these two should have a resultant momentum of polonium, because polonium is decaying into alpha and Pb. So momentum of the second alpha particle and momentum of the Pb must be equal to momentum of the polonium. Okay, right. So momentum of the polonium is equal to momentum of the first alpha particle. Okay, so now we need to draw a vector diagram or sketch a vector diagram that includes momentum of the first alpha particle that is equal to momentum of the polonium, then momentum of the second alpha particle and momentum of the Pb. So I can replace this momentum by momentum of the first alpha particle. I can say P1 alpha. So the vector diagram for the second part should be like this. The same line should be drawn this way. P1 alpha. This is P2 alpha for the second alpha particle. Same thing I am drawing here. I replace this line, which is momentum of polonium, by momentum of first alpha. Both should have the same momentum. I already explained. They should have the same momentum because radon was at rest. So momentum of radon is 0. Right. So this is momentum of polonium is this way, mean momentum of first alpha is this way. So the momentum of Pb should be this way. And this angle 60 degree. So this is the answer for the second part of question number 17, B, part B. Question number 17, this is the answer diagram. Okay, so third part. So I already drew the diagram and vector diagram. So this was the diagram. Momentum of first alpha, momentum of second alpha, Pb. I complete the diagram like this. So I'm going to answer the third part now. Question number 17, third part. Okay, so determine the magnitude of the velocity of the lead ion. So velocity of the particle emitted by radon, the alpha particle velocity is given 1.74 10 to the power 7 meter per second. Velocity of alpha particle emitted by the polonium, that is the second alpha particle, that velocity is given 1.81 10 to the power 7. Mass of the lead is given 3.52 10 to the power minus 25. Mass of the alpha is not given. We can calculate it because we know mass of alpha is 4 times the mass of proton. Mass of proton is given in the data sheet. So we can find the mass of alpha 4 into 1.66 10 to the power minus 27. That will be 6.64 10 to the power minus 27. Okay, I need to find the velocity of the Pb. Okay, by using the vector diagram. So this is the vector diagram. We drew it in the previous part, part 2. Momentum of the alpha, momentum of the second alpha, Pb. So we need to find the speed of the lead nucleus. Okay, how can we find it? So there we first I can say mass of the alpha particle is 4 times 1.66 10 to the power minus 27. So that will be 6.64 10 to the power minus 27 kilogram. Okay, so we need to find the momentum of first alpha because speed is given. Momentum of first alpha, that is equal to mass of alpha. We know that 6.64 10 to the power minus 27. into the speed of the first alpha is given as 1.74 10 to the power 7. So that will be 1.155 into 10 to the power minus 19 kilogram meter per second. Same way, moment of the second alpha is equal to mass of the alpha 10 to the power minus 27 into speed of the second alpha, which is emitted by the polonium, is given as 1.81 10 to the power 7. So that will be 1.20 202 10 to the power minus 19 kilogram meter per second. Okay, so now we'll think about this vector diagram. Okay, how can I solve and find the momentum of this line? So this is the vector diagram. So I'm not going to sketch according to, I'm not going to draw according to uh, I'm not going to draw according to scale. So I'm going to do a calculation. So I name this triangle. I'll call A, B, C, D in this triangle. I know this length that represents this value. I know this length. I know this angle. So if I find the length AC, that is AB plus BC is AC, then if I find the CD for the triangle ACD, I can use Pytherus theorem and find the length AD, that will be the momentum of PB. So I'll find the BC in this triangle. So that's a vertical component of the second alpha. So I can say AC is equal to AB plus BC. The length AB is first alpha 1.155 10 to the power minus 19 plus BC is equal to P2 alpha cos 60. P2 alpha is 1.202 10 to the power minus 90 times cos 60. Find that value. So that value will be 1.76 10 to the power minus 19 kilogram meter per second. Same way, find the CD. The length CD is equal to P2 alpha BD sine 60. BD is the length for the second alpha particle, that is 1.202 into 10 to the power minus 19 sine 60. So that will be 1.04 10 to the power minus 19 kilogram meter per second. So in the triangle ACD, I can say AD squared. AD squared is equal to AC squared plus CD squared. AD squared represents momentum of PB squared is equal to AC squared 1.76 10 to the power minus 19 all being squared plus CD squared 1.04 10 to the power minus 19 all being squared. So find the momentum of PB. So that will be 2.04 10 to the minus 19. Momentum of PB is equal to mass of PB. Mass of PB is given in the question, that is 3.52 10 to the power minus 25. So 3.52 10 to the power minus 25 into speed of PB is equal to 2.04 10 to the power minus 19. Find the speed of PB. So you will get the answer. Speed of PB will be equal to, final answer, 5.81 10 to the power 5 meter per second. It's an interesting question. So I wrote the diagram, then I wrote this one, then this one, then I wrote this one. So not in order. So first this one, then this one, then that one. Okay, C part little difficult. They are saying the photograph shows another pair of tracks follows random decay. So following random decay. So they are saying deduce which track is for the first alpha particle emitted. So you know there's a small gap between these two. So which one is the first alpha particle? Which could be the first alpha particle? Okay, so another track. So that not the earlier question. This is something new. Again, the decay happened. So there they got two tracks like this. So which one is the first alpha? First alpha means when radon decays, it produces alpha. Then and polonium. Polonium decays and produces another alpha and Pb. So the first alpha means the alpha produced when radon decays. Okay, now look at here. When radon decays, it produces alpha and polonium. Polonium will be recoiled. So that happens in a very short time. It recoiled and decay the second alpha. Okay, if the polonium, if the radon was here and if it emits the first alpha this direction, okay, then the polonium will be recoiled this way and emit the second alpha. So there will be a gap something like this. If this is the first alpha particle, this is the second alpha particle. Am I right? Think about the other way. If the radon decays the first alpha particle this way and radon decays and produce polonium, polonium recoil this direction and emit the second alpha this way, then there will be a gap like this. So given diagram has a gap like this, not like this. So this is the track of the first alpha particle. This is the track of the second alpha particle. So you should write that explanation in your answer. You have to look at the diagram carefully. Bit difficult, not easy, but that's the only answer I can say by using the recoil polonium nucleus. Okay, now question number 18, that is about linear accelerator. So they are saying the diagram is given. So the electrons used in the LINAC are produced by filament in an electron gun. So that's a thermionic emission. Name and describe the process in which electrons are produced by the filament. So you can say thermionic emission. Answer should be like this: thermionic emission. When certain atoms absorb heat, they vibrate and release the electrons. That process is called thermionic emission. B part, the diagram shows part of a simplified linear accelerator diagram is given. An electron enters the LINAC from the electron gun with a speed of 2.5 10 to the power 6 meter per second. The electron passes through 60 drift tubes before emerging from the other end. Calculate the energy of the electron as it emerges. Potential difference between the adjacent drift tubes is given 80 kilovolt. So you know gain in kinetic energy, the electrons will gain kinetic energy in the gap between the drift tubes. So gaining kinetic energy is equal to work done by the electric potential, W equal QV. So there are 60 drift tubes, means there will be 59 gaps there. So I can say gain in kinetic energy is equal to QV times 59. So the question is calculate the energy of the electron as it emerges. So gaining kinetic energy final minus initial kinetic energy. We can find it, the speed is given for the electron. So half into 9.11 10 to the power minus 31 into 2.5 into 10 to the power 6 squared equal. They ask me to find the calculate the energy of the electron as it emerges. So I need to find the final kinetic energy. Final kinetic energy equal initial, final kinetic energy I need to gain. So gain in kinetic energy is this equation. Gain means final kinetic energy minus initial kinetic energy equal to charge of electron 1.6 10 to the power minus 19. The potential difference applied across the gaps is 80 kilovolt, 80,000 into 59. Solve it and find the final kinetic energy. That will be 7.55 10 to the power minus 13 joules. So this is question number 18, first part. Okay, second part. For very high energy electrons, successive drift tubes have the same length. We learned that normally the length of the tube should increase along the direction of motion of the particle. Normally we say that for that, when the particles are accelerated, their speed will increase, but they'll spend the same amount of time inside each drift tube. Therefore, according speed equal distance over time, they spend the same time, but the speed is increasing. So the length of the drift tube should increase. We know that. But the question here is different. For very high energy electrons, the electrons have reached very high speed, almost speed of light, closer to speed of light. When they reach that speed, successive drift tubes have the same length. Explain why. So you can see when the electrons gain very high energy, what happens? When you accelerate them more and more, they will gain energy without gaining the speed. The mass will increase. You know that we normally teach that according to E equal mc squared. When you apply more and more energy after the electrons or the particles reaches almost closer to speed of light. So what happens when you give more and more energy, the kinetic energy will increase, the energy of the particle will increase, but not the speed increase, the mass will increase. So the energy increases because of increase in mass, not because of increase in speed. So speed will remain almost constant when it reaches very high energy, very high speed. So speed remains almost constant. So first answer, I am not writing it. You can say when the electron gains very high energy, you can see the speed will be very closer to speed of light and it remains constant. Therefore, according to speed equal distance over time, the particles spend same amount of time. Therefore, the length of the drift tube also should remain the same. That should be the answer for second part, B part. Okay, C part. Linac used for radiotherapy operate by means of standing wave. So normally we don't teach that standing wave. Actually, what's happening there? Standing wave is the electric field. Electric field is produced such that it forms a standing wave inside the linac. Anyway, we don't need to worry about it because question is explain how standing waves are produced. So it's like a unit 2 paper. In unit 2, you learn how standing waves are produced. So the question is explain how standing waves produced. The question is nothing related to LINAC. Simply explain how standing waves are produced. So you can say when two identical oppositely traveling waves overlap, at certain points they overlap in phase and due to constructive superposition, they will have larger amplitude of oscillation and that is called antinode. At certain points, they always overlap antiphase and destructive superposition will occur. Amplitude will become equal to 0 and at those points, node will be formed. You know this is unit 2 question actually. So here electrons emerging from the standing wave linac must be directed towards and they are showing 270 path deviation. So determine the magnetic flux density required to rotate the beam 270 degree. Energy of the electrons is given 2.5 kilo electron volt. Radius of the curvature of the path 61 millimeters. So the radius also given. I need to find the magnetic field strength. Okay, so to turn the path of the electron like this. So I know the kinetic energy equal P squared over 2m. Kinetic energy is given 2.5 kilo electron volt. Kilo means 10 to the power 3 into 1.6 10 to the power minus 19. Converting electron volt to joule is equal to P squared over 2m 2 into 9.11 10 to the power minus 31 for the electron. So from this find the momentum. So momentum will be 2.70 10 to the power minus 23 kilogram meter per second. Okay, then you can use the equation R equal T over BQ given in the data sheet. So we know the radius that is given as 61 millimeter, 61 into 10 to the power minus 3 equal. Momentum given 2.70, 10 to the power minus 23. Magnetic field strength is the question. Charge of the electron 1.6 10 to the power minus 19. Find the B, you will get 2.76 10 to the power minus 3 Tesla. Okay, again, that's the end of this paper. So in this lesson, I discussed questions from question 14 to question 18. In my previous lesson, I discussed the same paper from question 1 to question 13. And the URL or the link for the video of the previous lesson is given in the description of this video. So you can find it there. Okay, right. Bye.